Welcome, everyone. It's great to see you all here again this morning. I hope you enjoyed yesterday as much as we did. We had an amazing group of speakers, and we were all just kind of buzzing afterwards and this morning talking about all the different kinds of insights and the progression of this whole water data community over the years. And it's just, it's incredible. Way more than I was expecting, to be quite honest, of a feeling of accomplishment collectively, and just, you know, a sense of honor to be part of this community. So I hope you're all well rested and ready for another day. We have a full day of events. Although the symposium ends in the early afternoon, we have right afterwards, after a short break, we have a workshop diving into the Delta data Tableau ecosystem that was just discussed and introduced yesterday morning. So hopefully you can stick around for that. If not, enjoy this morning and the session that goes into like the early afternoon. And we are also here to honor some of the work that's been done and traditional ecological knowledge that has been provided over the years. So we have a really exciting day. So looking forward to all the speakers and all the participation from all of you. So thank you. We're going to review some of the logistics here. So this is being recorded as we've discussed before. It's also being streamed over on a YouTube channel that will provide the link, or the link has been provided. We ask that you use the Q&A function to ask questions of the panelists. If you have technical questions, we ask that you email Anna at her email address there. This worked pretty well yesterday. We did get a few people that raised their hands. We can't really respond to raised hands. We can't empower people to speak. So you have to basically type in your question into the Q&A interface. That's how we're going to do it. So I want to thank the panelists who got here this morning to help us get ready. We are, I think, ready to go and have a really great discussion. So first, though, I would like to welcome a special guest. We have a surprise here. So I would like to welcome a special guest who will introduce himself, and go ahead and advance, please.
Good morning. Just wanted to say I'm honored to be here today to be part of this conference that's going on. My name is Brian Tripp. I'm a member of the Karuk tribe of California. I recognize and identify as Karuk Ada. Karuk in my language means upriver, and Ada means person. So I look at myself as Karuk Ada. We named ourselves after the river. That's how important it is to us. It brought all of the fish and all the things that live in it, and all the things that depend on it. And one of those things is my people. We live in the middle stretch of the Klamath. The Yeroks are below us, and then the Klamath tribes up above. And right now our river's so polluted. Right now it's being continued to be every year. It gets lower and lower. The pollution becomes worse and worse. They talk about taking dams down, but they don't. We need something done. And then people are trying to take it even more and taking it south. Something has to stop someplace. And I'm hoping it's not my tribe. So I'm glad to be here today, and the poem that I'm going to read, well, the song is actually a song. We believe in power of song, power of prayer. And my poem is it's called In the Spawning Ground. So I hope you listen and take it to heart. Thank you. Hayad, hayad, hey, hey, Hayad, had, hayad, hey, hayad, had, hayad, hey, ho, and he, ho, and he, do, and he, ho, and ya, ha, hayad, hey, hayad, ha, and hayad, hey, hayad, ha, and hayad, hey, and he, and he, and ya, hayad, hayad, hey, hayad, 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 hey, hayad, 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 hey, I am from the spawning ground. It's the one that we all know. At one time or another, we all swam from the same hole. That's when my water broke. That's when my father spoke. He said, when I was young, I was told, know how the water tastes, know which way it flows, feel the wind, know which way it blows, learn from the animals, the birds and the bees, say a prayer for the home ground, the rivers, the rocks, the mountains, the ocean and trees. Always give more than you take. Always work hard for the people's sakes. Don't tell lies. Do things right. Sing your own song, and you won't be wrong. So, what I know is what I owe. Take it, use it, then put it back in the ground where it was before it was found. And then give it water, let it flow. Give it light and make it bright and let it glow. With love, with respect. That way, that day, we all can grow. Yotwa, yotwa, yotwa.
I want to thank Brooke Thompson for her help in organizing and arranging the video. I watched it a lot of times, but I wasn't as affected as I was this morning. So I'm going to hand it over to Allie, who's going to help introduce the next session, and I will share my screen, and I'll be back with you guys. And so thank you, everyone.
Thanks, Greg. I have a similar reaction. I tried watching the video yesterday so that I wouldn't be emotional today, but here we are. That was beautiful. And I really can't think of a better way to kick off this next session. Let me get the, hang on, sorry guys. Greg, are you sharing? You're up? Okay. This next session is really about kind of the interconnectivity of things, and as in Brian's song and prayer, I think it really touched on that, you know, and I'm like thinking, man, the water boards, maybe we should change our mission statement to match that song. It really hit hard. So this next session is the California chapter of Society for Freshwater Sciences. My name's Allie Dunn. I guess I should introduce myself. I oversee the surface water ambient monitoring program throughout the state. We've got several monitoring programs. The one most related to this session is our bioassessment monitoring program, where we look at what's living and what's alive in the streams, right? And what better way to tell the health and condition of our freshwater ecosystems than what's alive and living there. Yesterday, you heard from the board chair talking about the work that we do, and you know, he highlighted that macroinvertebrates and algae matter, right? So this panel today, the session is going to talk about freshwater science, and these are early career scientists. Angela de Palma-Dow will get into the details of that, so I won't talk much more other than to say I'm super honored and excited to introduce this session and hear from this incredible crew of early career freshwater scientists. And with that, Angela, are you on?
Yes, I'm here. Can you hear me?
Hi, yes, loud and clear.
And you can see me?
Yep.
Okay, great. Thank you so much, Allie. So
Sure.
I did request remote control. There we go. Okay. All right, so thank you so much. Today I'm going to talk a little bit about the California chapter of the Society for Freshwater Science. And then we have a special session that's showcasing some of our Cal-SFS fellows. So we're really trying to showcase the future of freshwater through this chapter and through our society today. And I want to acknowledge, I'm the chair president of the chapter, and then also our treasurer secretary, John Olson, as well here. And you can follow us on Twitter at Cal-SFS Social. I think the little box might be covering up the Twitter handle for me, but go ahead and you can move that and go ahead and follow us on Twitter. So again, I want to thank so much the Water Data Source Science Symposium today for allowing us to have an entire special session this morning to showcase our fellows. And then we really want to thank the Society Freshwater Science Long Range Planning Committee for supporting these fellows. So they provided a basically the fellowship funds for us to be able to have this fellowship program. And that's the Long Range Planning Committee through the Society Freshwater Science. So if you're unfamiliar, the Society for Freshwater Science is an international scientific organization, and the purpose is to promote further understanding freshwater ecosystems, such as rivers, streams, lakes, reservoirs, and estuaries, and ecosystems at the interface between aquatic and terrestrial habitats. And so specifically, SFS, or Society for Freshwater Science, promotes and fosters the exchange of the scientific information among the membership, as well as promotion with this engagement among other professional societies, as well as resource managers, policymakers, educators, and of course the public. And we really feel like the mission of the society and the purpose of the Data Water Symposium align very closely. Basically, the society started in 1953. Right now we have over 1,800 members, and it is an international organization. So these memberships span across the globe. And basically the defining feature of SFS is the investment and commitment the society makes to interdisciplinary, international, interinstitutional exchange and mentorship, particularly among young scientists. And that's what really makes SFS a leader in integrative aquatic science. Particularly for the California chapter, we're really trying to uphold these, the mission for SFS within our own state and the surrounding region. So we really have this focus on aquatic research, application, and policy for all and by all in California ecosystems, ecotones, bioregions. And so this is a really great opportunity for the chapter here today for the symposium to be able to share that mission and expand upon it. And a little thing about, or some tidbits about the chapter is we are the only state-specific chapter of SFS. We do have annual meetings that coincide with the California Aquatic Bioassessment Work Group. So we have one coming up in October that'll advertise later. And we do have an annual winter newsletter every year that kind of covers what we've accomplished, what our plans are, and then kind of, shares what our students are doing and what other members of the chapter and the society are doing. And then we had only 33 members in 2020. COVID hit us pretty hard. So we are looking to get our membership back up. I think at the most we had 180. And we really want to expand this membership and encourage, if you're interested in freshwater, if you're a student, if you're an early career scientist, or if you, have been in the field for a while and you have mentorship desires and capabilities, we encourage you to become a member in our chapter. And then these are some of the SFS core values, and these have been identified in the Society's 5-year strategic plan. And so as a regional chapter, we really are trying to promote and meet each of these core values, particularly supporting developing freshwater scientists, as well as advancing diversity, inclusivity, and equity in freshwater science. And to do this, we started this fellowship program this year. And so this is our guinea pig cohort. You guys are awesome for being the trial for this. And basically the fellows, they serve for a year. They present at the annual SFS meeting. They participate in our Cal-SFS meeting. And then this is like a bonus. So they're presenting here today too at the Water Data Science Symposium as well. And then they are awarded a stipend for being fellows. And we wanted to make sure that that stipend fit their needs, what they needed. So it's beyond just travel funds. They can use it for research equipment. They can use it for help publishing. They can use it for travel if they want, or anything else. We wanted to have this flexibility support there for the fellows so they can accomplish what they want during their fellowship. And then we can encourage them to continue being members in Cal-SFS and SFS for the betterment and future of freshwater. Some other things we did as part of the fellowship is to waive registrations. And then we also have some mentorship and networking opportunities. So if you're working for the state and you are thinking about, sharing some information, you can be a mentorship, please reach out to Anna Holder. We are working to connect our fellows with some agency state personnel to try to, encourage the cross interaction, interdisciplinary nature of this program. And again, it's a trial year. So I might present next year on what we learned and talk about our next cohort of fellows. And so these are the fellows. I'm so excited. They're going to be here over the next hour or so to talk about some of their topics. So we have Kyle Leathers. This is from left to right. Robin López, Alyssa Obester, William Oda, and Melissa von Mayrhauser. And I'm just so excited for you guys are here. You can follow us on Twitter, learn more about their research. And they're going to be talking about things like what's a natural river, Southern California urban rivers, ecological racism, seeking equity and justice, thermal vulnerability in Sierra Nevada streams, functional flows in the Eel River watershed, and Santa Ana River working extremely disturbed system. So it's a broad scope of research that both these students and early career scientists are covering today. And I'm just so thankful and excited that they're able to share their research and what they're doing and what they're going to be doing here at the Water Data Symposium today. And so again, thank you so much for having us. And if you are interested in joining the chapter, you can email us at cal.chap.sfs@gmail.com. You can also reach out to us via Twitter. We have some communication ambassadors that would love to talk with you and be able to, get you hooked up with being a member. And then we'll go right into the next session. Thank you so much, Ali, for moderating this today. And again, thank you to the symposium for allowing us to have this special session. And good luck to all the fellows. I'm really excited to learn about what you guys are doing.
Awesome. Thank you, Angela. And we can, if folks have questions for Angela, she's going to close the session out as well. So feel free to hold on to those questions and shoot away at the very end. So with that, I'm going to transition to our next speaker, Alyssa von Mayrhauser. Sorry, totally botched that. Mayrhauser, where she's going to talk about, what is a natural river and how we can understand ecological opportunities and cultural values as flows decrease in Southern California urban rivers. Alyssa, are you on?
I'm here. Good morning.
Okay, great. Good morning.
Thank you, Ali. Yes, my name is Melissa von Mayrhauser, and I'm a freshwater ecology PhD student at UC Berkeley and a proud Cal-SFS fellow as well. Thank you to Angela and John from Cal-SFS and the Water Data Science Symposium for the chance to speak this morning. I'm really excited to be here. And I'd like to ask you this question that is often on my mind, which is, what is a natural river? And I think about this a lot because I work in a lot of highly modified urban rivers, two of which I'm going to tell you a bit about today. I'm going to be talking with you about some of my research ideas as I finish up the first year of my PhD, so I'm still at the beginning. And yes, I'm seeking to understand these ecological opportunities and cultural values as flows decrease in Southern California urban rivers. Okay, so I'd like to, let's see. Here we go. I'd like to begin by introducing two of my wonderful study rivers to you, not with their names yet, but with these satellite images. And the river on the left is often called one of the last remaining natural rivers in Southern California, since it remains largely ecologically intact. Whereas the river on the right is often no longer called a river, but instead a flood control channel in some cases, due to this legacy of channelization where a lot of the river was encased in concrete. But these rivers really have a lot in common. They both have Mediterranean climate flow regimes, so really flashy hydrologies going from low to high flows, sometimes very quickly. They're both located in a global biodiversity hotspot, and they also share a watershed border, so they're sort of sister rivers. These are the Santa Clara and Los Angeles rivers, and they are part of the ancestral and unceded watersheds of the Chumash, Kizh, Tataviam, and Tongva people. And these rivers have always held and continue to hold great importance to these tribes, and I'm really honored to be a guest in these watersheds as a researcher. And something these rivers have in common as well is that the majority of their flows along their main stems, like the ones you see in these pictures here, have come from treated wastewater discharge, also known as effluent, since the mid to late 20th century. And these effluent discharges have really transformed these rivers' flows from being lower and more variable to being higher and more consistent. And these changes have led to the development of these new types of ecosystems and new social uses. So these river reaches now support this combination of species that are much more adapted to higher, more stable flows, from endangered species like the three-spined stickleback in the Santa Clara to wading birds like the black-necked stilt, and invasive species like the giant cane or arundo here. And these river reaches also support a variety of social uses that wouldn't necessarily exist without these higher flows. In some of these reaches, like fishing and kayaking and appreciation for biodiversity. But the policy landscape is really changing in California. And following California's last extreme drought, the State Water Board implemented its policy, the Water Quality Control Policy here for recycled water, which really encourages wastewater treatment plants to recycle a lot more water rather than discharging as much of it into waterways. And this has led to exciting research like at the Southern California Coastal Water Research Project, looking at how these effluent reductions will affect river species and habitats and beneficial uses. And here we are in the California on the right in so much red. Once again, we find ourselves in a state of drought, and extreme and exceptional drought in some cases, which is really increasing a lot of the urgency experienced right now around the need to increase local water supplies, such as through recycling more wastewater. And at the same time, we have a lot of active planning processes happening, especially in the LA River watershed, where we're asking the question that we see from the LA Times in the upper left here: what role should the LA River play in a future Los Angeles? And there's a lot of excitement around this idea of bringing nature back and what that means. And from my experience working, going to a lot of different planning processes during my time working at a nonprofit, LA Waterkeeper in LA, I really have noticed a disconnect in some of these planning processes between the reality that within the next few years, there likely will be this big reduction in flows in these in the LA River because of the effluent discharge reduction. So there's a disconnect between that reality and a lot of the planning processes that sort of take for granted a lot of the flows existing as they are there now. And in the meantime, a lot of people are being overlooked who depend on these flows for a lot of basic needs, such as we see in this article from the High Country News. So there are a lot of conversations happening now with the LA River around what natural would mean with restoring it. And at the same time with the Santa Clara River, my experience has been it's often sort of taken for granted. It's already natural, it's already the last of its kind. So it doesn't receive the same spotlight, even as a lot of development is encroaching into its riparian areas right now. So in the context of these upcoming reductions in effluent discharges and really varied approaches to revitalization in these urban rivers, I wonder what our goal should be with restoration projects. And one question I ask is, should our goal be to restore rivers to a natural state? And I think this is such an interesting question because from going to a variety of meetings, I've heard very different takes on this. For instance, with the conversations around effluent reduction, a lot of conversations have been, well, that would be more natural because we're returning to a natural flow regime without the unnatural effluent. At the same time, I've heard conversations of how we have to keep a lot of water in the river because people only recognize the river as natural if it has flow. And without effluent, a lot of segments or reaches of the river will run dry. So that's all to say, there are a lot of different perceptions and metrics that we could use. And I think as I launch into my research, it's really critical to think through this question and ask a lot of people what they think, especially from management agencies, from tribes and nonprofits representing people from across Los Angeles, because I certainly do not have the answer to this question, but I'm quite intrigued. So as I'm thinking about this, I wanted to tell you about some of the different types of methods and data I'm starting to use as I think about this question of what a natural river is and how changes in river flows affect people and ecosystems. And I think we need a variety of approaches. So these range from analyzing remote sensing and gauge data to monitoring aquatic and terrestrial invertebrates, to analyzing community collected bird data, and also conducting a human perception survey. So I'm going to tell you a little bit more about these different approaches. And I think it's really important to understand how flows in vegetation have changed over time so that we can prepare better policy now. And I'm thinking about this in terms of compiling flow gauge data, wastewater treatment plant discharge data, looking at monitoring efforts that are already happening, such as from the Stormwater Monitoring Coalition, and integrating these efforts with remote sensing data. I'm also thinking about how to bring in historical and local knowledge that spans well beyond the timeframes of remote sensing and gauging tools to be able to answer some of these questions. I'm also building on the rich history of aquatic invertebrate monitoring that's been carried out by the Stormwater Monitoring Coalition. And I'm monitoring aquatic and terrestrial invertebrates upstream and downstream of effluent discharge points. So here, for instance, is the Santa Clara River, and these two pictures are only steps away from each other, but you can see quite a difference in the ecosystems between the place where effluent is discharged versus upstream. And I think it's especially important that we integrate terrestrial invertebrates into our monitoring of these stream segments, because with the likelihood that more and more of these reaches will run dry in the future, the terrestrial invertebrates are becoming more and more important indicators of dry stream health. And finally, I'm really interested in how people interact with rivers and are experiencing these changes in flows. And so I'm starting to analyze data from the community-driven applications iNaturalist and eBird, looking at how people's observations of birds along rivers change over time as flow levels change. And I'm also planning to carry out a survey in the future, thinking through some of the questions I've been asking of you today. And so here's an example of something I'm interested in that maybe you'd want to ask yourself as we look at these pictures of which river segment pictured here is more natural. And of course, I don't have an answer, and I'll leave that as a rhetorical question for you. And just speaking of flows, it was great to participate in the annual Society for Freshwater Science conference this year and co-moderate a panel with my advisor, Dr. Ruhi, and postdoc in my lab, Dr. Colombano, about scaling the effects of flows across time and space and biological organization. So I appreciated the chance to speak with researchers from across the world on some of these questions, and I hope we can continue these efforts. And I wanted to close by really thanking the California chapter for the Society for Freshwater Science, as well as my department at UC Berkeley, Environmental Science Policy and Management Department, partners at SCWRP, the Southern California Coastal Water Research Project. And I'd like to sort of offer a special thanks to Drs. Ruhi, Grantham, and Mazur for all of your support. And finally, here's my contact information at the bottom. And if there's anything that has stood out to you where you're interested in speaking further, share some thoughts, think about collaboration, or maybe you just want to have a philosophical debate about the meaning of natural rivers, then please feel free to reach out. And thank you so much again for this opportunity to speak.
Thank you so much, Melissa. And I think you really hit it on the head that our freshwater systems are so complex and so complicated from one system to the next. I think you're sitting in the LA River in your background, and I'm at the McCloud, and look at the stark differences between those two, and each have their challenges. So thank you so much for your work on this. I'm going to turn it over to see if we have any questions for Melissa. I think we have time for at least one question.
We do. Do you think that the state and local governments should discourage urbanization in the Central Valley and other areas with little to no water?
Okay, so again, do I think that governments should discourage? Could you say that one more time?
If you think they should discourage urbanization in the Central Valley and other areas with little to no water.
That's an interesting question. Because urbanization could mean so many different things. And I think that certainly the availability of water and clean water is an important factor to consider. And there are many ways of approaching urbanization, I suppose. And there's a lot of, there are different approaches, like there's urban sprawl compared to really trying to build sort of these centers of urban life that'll have lower environmental impacts, for instance, and be more efficient. So it's difficult to answer that question, not knowing more about the context, but I'd be curious to hear more of your thoughts.
Understood. And we have one more. How do you think we could use terrestrial insects to understand stream health?
Yes, thank you, Kyle, for that question. I think that as we think about the ecological importance of our dry stream beds, we can sort of start to monitor terrestrial invertebrates so that we can think about them as indicators of the health of these sections. Because if there's no water, we can't monitor aquatic invertebrates, of course. And so we still need a way of measuring the health of these sections. So there's a lot of exciting science that's happening now around sort of developing indices and indicators around terrestrial insects when a lot of the energy has been devoted to aquatic invertebrates previously. And so there are a variety of methods we can use. And so I think it's a growing and exciting part of aquatic or freshwater ecology and thinking about including terrestrial insects.
Great, thank you.
Okay, thank you so much, Melissa. And then, so next we have up Robin López. Robin will be talking about ecological racism and seeking equity and justice via social and cultural competency. So super excited to hear from you, Robin. This is kind of a newer topic that we've all been really interested in, newer as in presenting via a conference. So take it over, happy to hear from you.
Thank you. Let me make sure I got the remote control set. There we go.
Cool.
Everyone, yes, my presentation, Ecological Racism, Seeking Equity and Justice via Social and Cultural Competency. My name's Robin D. López, pronouns are he, him, and this is presented in collaboration with one of my PhD advisors, Ted Gransom, out of UC Berkeley, and another collaborator named Matt Cover out of CSU Stanislaus. Before I jump into anything, I do want to acknowledge and actually take a few moments of acknowledgement. This first moment of acknowledgement is to the Cal-SFS Fellowship Program. It's allowed me to attend my first annual SFF meeting. As well, it's allowed me to present as the primary author on work intersecting freshwater and social dimensions. It also enabled me to interact and engage with many new peers who have similar interests in the areas of environmental justice and ecological integrity. And in a way, I was able to develop a sense of belonging within this specific space at the SFF meeting. As I'll be entirely honest, when I typically go to conferences, I do not feel a sense of belonging. I do not feel like these spaces are crafted for my voices or the voices of my community to be taken seriously. And so I am appreciative that I'm able to be here today to speak on an issue that is very near and dear to my heart. But more than just an issue that I think warrants attention. It's an issue that for many of us is, renders itself into a life or death situation. So I hope as you all hear what I have to share, you hear with an open heart and an open mind. I understand there may be some hesitancy due to vulnerabilities, but I do ask that you please take a moment. In terms of further acknowledgement, I do want to give formal land acknowledgement before we move forward. I'd like to take the moment to recognize the space I currently occupy as Ohlone land, Richmond, California. And I also like to recognize the indigenous knowledge that has afforded us the privileges of using such environment, such as my home communities of Oakland, Richmond. And I challenge all of us to think critically about how we can decolonize such spaces and decolonize ways of thinking. And also this intersects into this issues of continuous racial and social injustice. And I believe this is a good segue into talking about ecological racism. In a time of deep reckoning with racial and social injustices, it's imperative we leverage our positionality to truly catalyze change. As rising researchers, educators, scientists, and several in here policymakers, we're not immune to the trauma of this world, nor are we exempt from engaging in the necessary and uncomfortable dialogue. The work we do in academia and science has direct and indirect impact in upholding systemic and institutional barriers. And if you're not familiar of this image of this young boy, this is Adam Toledo, who was recently slaughtered by the police in Chicago. And when I made this presentation, this was before I was recently harassed and racially profiled by the police a couple weeks ago. And so I'm not sharing this to take digs at police, but I'm sharing this to also highlight that something as simple as wanting to interact with the green space or with our natural water system is not as simple as it is for people of color like myself. We can't just venture off into some of these green spaces and feel safe without having to be profiled or having to be stopped by folks who say we look like we don't belong there. And my final moment of acknowledgement to my mentors and advisors, folks like Ted Grantham, Matt Cover, whom are the co-authors of this presentation, that move as accomplices, not just allies, for the growth and development of historically marginalized identities, as well as my co-advisor, Paulo Diodorico at UC Berkeley, another individual who listens with sincerity and seeks to make a more just and equitable space in our Department of Environmental Science, Policy, and Management at UC Berkeley. And I guess before I move forward with anything else, I guess I would assume it's appropriate to also give brief background on myself. As you heard previously, out of Oakland, was raised in Richmond, California, two communities that have been hyper-villainized and hyper-criminalized in the lens of the media as very violent spaces. And that is not how I've ever seen it. I've seen both those communities as places of love, places of growth, and places of comfort. But with that said, due to the way we are perceived and how we are treated, that had led to severe underfunding and under-resourced allocations for our educational system. And as a result, I barely graduated high school. And I also come from an indirectly system impacted background. And with those two issues combined, I was not at all prepared for college. I had actually dropped out several times trying to navigate my way. And it wasn't until age of 21 when I switched my hustle after several traumatic events, friend being murdered, incarcerated, and best friend unfortunately dying by suicide, that I decided to go back to school and try to find something that's a bit different. And today I stand before you at the hood ecologist. I'm a researcher at the Lawrence Berkeley National Lab, where I've been since 2012. And as you're probably already aware, PhD candidate at UC Berkeley in the Freshwater and Ecohydrology lab group. I would say that's it in terms of talking about myself for background. And this is where I really want to get into the nitty gritty, particularly that representation matters. Statistically, I'm not supposed to be here. And few scholars navigate these spaces safely that rise from similar historically marginalized environment. Anecdotally, interactions and perceptions of nature are very different for me, as I previously alluded to. and folks like us are not afforded equitable access, exposure, and resources to actualize respected potential, especially in the field of freshwater ecology. And so methods of scientific outreach are severely inadequate. There are well-intentioned efforts that can be acknowledged, but most programming all seems like shallow efforts of diversity. And our communities are drowning in these shallow waters of outreach. That critical information and exposure is locked heavily within the ivory tower of academia through various forms of gatekeeping. And along these shallow waters, though, are deep roots, literal and figurative roots that interconnect with the subsurface, vast mysterious connections waiting to be explored and explained. And that dives into this idea of habitat restoration and ecosystem protection, particularly around water. We talk about this often, but seldom does academia interact with original land stewards, native and indigenous knowledge, who did an amazing job in maintaining and protecting ecosystems for thousands of years and continue to do it to this day and continually are overlooked by academia. And so I think about the ecological integrity of my own research in Northern California and the Russian River watershed, fish survival and migration in response to climate change, drought, and groundwater influence, Northern Alaska's Arctic ecosystem when I'm analyzing frozen soil to contextualize the impact of climate change, our stream restoration nationally, assessing where restoration is prioritized and what level of investment is provided. Spoiler alert, it's not equitable, but are we surprised? And so that goes into this idea of ecological racism. And I'm sure you all are just dying to learn and find out what is ecological racism. You've heard environmental justice, you've heard of environmental racism. And so now you're wondering, what is this dude coming through talking about ecological racism? Well, I'm here to wake you up. Ecological racism refers to ecosystems largely occupied and utilized by historically minoritized and marginalized identities that are exploited, extracted, are restored without regard to impacted communities. Consequently, these critical identities and voices are missing from the spaces of environmental science. Therefore, there is a need for addressing issues of ecological racism via social and cultural competency. And so now you know, so now what? Just as freshwater ecology recognizes that biological and functional diversity underpins ecological integrity, sustained meaningful effort to advance justice, equity, diversity, and inclusion have the potential to bring integrity to our research community. And before I move on to the next slide, I'll say, given that I only have 12 to 15 minutes to go into this, don't take this as everything that you need to know. Google it. You have access to so much information. And so all that said, in my own study side, I do think of myself as that coho salmon, trying to survive, and people want to help, but don't fully understand the problems needed to be solved. And I think of that out-migration process that we talk about often, a small fish in a vast ocean moving with the waters. We know that the fish is somewhere out there, but we don't know what it's doing to survive. We only know that if it survives, it finds its way back home. And that's an ecological story that I resonate with very deeply. And I share that to say, let's not wait to see if integral pieces of our ecosystem survive or not. Let's not wait to see if individuals like me survive academia or not, because there's so many more in not just my community, but similar communities that are trying to get access to that exposure, that are trying to bring their best whole self and their creative inquiry into these spaces, but they get gatekept by credentialized scientists or gatekept because of whatever respective identity that they may have that is marginalized in the system. So let's invest in the people in the community. Let's not extract. And so I'll close this out with some methods for addressing ecological racism. This is not a full-on comprehensive list, but maybe this will give you the tool set to start thinking critically about what needs to be done. And so it needs to be handled with intent and care. It needs to hold space and acknowledge the nuances and complexity of different experiences. It needs to ensure it's never complacent because the work never ends. It needs layers of accountability, and it needs participation from everyone. It needs more than just representation. It needs robust support financially, emotionally, and professionally. And it needs asset-based framework, because deficit model framework is not the business, and requires mutual aid, vulnerability, and advocacy. And so I'll close that out. Thank you very much for your time. If you're social on Instagram or Twitter, you can find me at Hood Ecologist.
Thank you so much, Robin. We appreciate you coming here today, and hopefully it's not, I know this was only 10, 15 minutes that we got to talk, but I hope it's the beginning of an ongoing conversation engagement with you over the next several years, hopefully. I want to turn it over to Peter to see if there's any questions for Robin.
We do, and I also want to thank you, Robin, for bringing your voice and your message to us. It was really powerful. Thank you. The question I have is based on your science, based on your experience, how can scientific societies and agencies reach out and make the pathway to aquatic science and application more obtainable, more available, and more accessible to those who traditionally have been underserved and or overlooked?
I would say that requires very region specific or location specific outreach. Again, because marginalized communities or minoritized communities, our identities, we do not operate as a monolith. We all have different needs, and that's where that social and cultural relevance comes into play. Understanding how a particular community takes in the knowledge transfer process, because it does vary from region or even neighborhood to neighborhood. And I would say one of the first things is don't assume that peer-reviewed published research is the way that people are going to have access to that knowledge. General public is not going around reading peer-reviewed articles. We need to find ways to make it more interactive, getting creative, and maybe making creative content that highlights our work while putting faces and imagery of people that look like folks from those communities. That way there's a sense of connection.
Great. I have another question. What would help integrate social and ecological and technical, I'm sorry, let me start over. What would help integrate social, ecological, and technical science better?
I think one of the best ways to answer that is allowing folks for their truth to be heard and their truth to be recognized and acted upon. To me, quite honestly, that's what it really comes down to. We often talk about having that representation or having folk come into the table to talk, but we often don't give those same folk the opportunity to have power at the decision-making table. There's still a system of imbalance. And so when we get closer to that, I think we also get closer to integrating those three components and having something that's truly intersectional, that is truly representative of our society and really raises the bar for ecological integrity as a whole.
Thank you. I have another question. Powerful and wonderful talk, Robin. Can you talk about accessibility for marginalized communities in traditional college pathways versus online education courses and boot camps, things like that?
So I'll be honest, I don't have too much, I don't feel like I have too much insight on that. What I can say is that into my own experience in the traditional college pathway, it helps a lot when you see professors that look like you or counselors that look like you, fellow students that look like you, who have those shared experiences and that collective experience to move forward with these studies and understand social and cultural relevance of whatever we're learning. And that context of online learning, that's not something I necessarily have experience in or have dove too much into, but I will say there is deep value to it because there are folks who do not feel comfortable entering those physical spaces of systemic oppression and institutional barriers. And that's something we need to acknowledge and recognize, that some folks flourish much better from distance learning or online based learning. Perhaps a silver lining to this pandemic and why we're in this virtual conference, folks are able to engage the educational process in a way that's comfortable for them without having any of their anxieties or traumas triggered in a physical space.
Thank you so much. I look forward to hearing more from you. That's all the questions we have.
Thank you very much.
All right, thanks, Robin, and thanks, Peter. Okay, so moving on to our next topic, we're going to hear from Kyle Leathers and thermal vulnerability in Sierra Nevada streams and looking at spatial scales and drivers. Kyle, turning it over to you. You there, Kyle?
It's not saying I can change my video or start it.
There you are. Hi.
Okay.
Hi.
All right. Now I should be good.
Okay, cool.
Let's see if I can get this to go. Great. Okay. I'm excited to share my results with everyone today on the spatial scales and drivers of thermal vulnerability in Sierra Nevada streams. And to start off, I'm a Cal-SFS fellow. I'm really excited to be a part of this special session, and I was lucky to present results from the first chapter of my PhD on how early low flows into Sierra Nevada, the result of climate change, can affect aquatic food webs, including both emergent insects and also terrestrial consumers like Brewer's blackbirds that were able to wade in streams at low flows and feed on aquatic insects, which they couldn't do during high flows. It's been great to see different state agencies and the work that they've done for this conference, and I'm excited to get to know more people for the rest of the time as a fellow. To jump into today's topic though, climate change threatens Sierra Nevada streams, starting with increases in air temperature, which are predicted to be 2 to 6 degrees Celsius by the end of the century. This increase in air temperature will lead to higher snowmelt rates, and it could result in snowmelt, which currently melts off in August and results in low flow in most of our streams in the Sierra, occurring up to 2 months earlier in June, which would lead to a much longer period of low flow. And this is concerning to water temperature and thermal vulnerability because low flows can reduce thermal buffering. They can increase the residence time as the water takes a longer amount of time to travel downstream. It has a longer amount of time to heat up as well before it reaches the same point. And it can result in increased overlap between minimum flow and maximum air temperature. And currently, max air temperature occurs during the summer around July or early August, while minimum flows occur during the fall for the most part. However, with climate change, not only would maximum air temperatures increase, but they would also occur almost at the same time as low flows during the summer, which would increase vulnerability. Despite knowing how all of these factors might change thermal vulnerability and impact water temperature, there's still some questions we have to figure out. These include when thermal vulnerability will occur temporally, where it will occur spatially, and why some areas might be vulnerable more so than others, which are the environmental drivers. And these are combined into my central research question for this talk: what is the thermal vulnerability of Sierra Nevada streams? This can be broken down into temporally, does air temperature affect water temperature during the summer, which is the critical time we have to consider, as that will be the time of max water temperature and air temperature potentially, and the thermal maxima that organisms might reach that could threaten them. We also need to understand spatially at what spatial scale is a stream vulnerable or resilient to climate warming. It could be that the entire watershed responds the same way to climate warming, and it's all either vulnerable or resilient. However, there could also be differences between pools and riffles. Maybe pools are more resilient because they have a higher amount of water that cools them down and increases their thermal buffering. Or there could even be microhabitat variation where each individual pool or riffle has its own unique characteristics that might affect their thermal vulnerability going forward. And then lastly, what drives water temperature, and do these drivers predict resilient or vulnerable watersheds going forward? To answer all of these questions, I deployed 52 water temperature sensors in Bull Creek, which is about 20 miles west of Kings Canyon National Park and close to Shaver Lake. And this is also within the Kings River Experimental Watershed, led by the U.S. Forest Service and Pacific Research Station. And they have 3 long-term monitoring sites there for flow and temperature. including a main stem site, B200, a small headwater, B201, and an intermediate site, B203. In addition to these sites, I deployed sensors in 10 50 to 100 meter reaches, which varied from the main stem of Bull Creek to intermediate sized segments of the stream to headwaters, which were mostly at higher elevations. And the sensors at each of these were measuring water temperature at a 15-minute time interval. And within each of these 50 to 100 meter reaches, we had a paired pool riffle design, where there were 3 pool riffles adjacent to one another at each had a water temperature sensor placed within them and an air temperature sensor placed within them to measure thermal sensitivity. And we used time series models to answer these questions for our first 2 sub-questions and a spatial model for the third sub-question, which I'll get to in a second. So the graph isn't showing up super great on my end here. I'm not sure why with one slide, but it should have been showing that air and water temperature are highly correlated throughout most of the year, while water temperatures are more moderate during the summer and winter. And this is just kind of background information, which I can share at a later time if you would like. And then for the actual results, for the temporal vulnerability, we used a DLM model, which is a dynamic linear model, which allows us to test how water temperature is affected by air temperature at very short time scales for every 2 days, rather than using a regression relationship that might average the relationship between air temperature and water temperature per month or per season. This allows us to get at a much higher temporal frequency, which is useful for understanding how sensitive it actually is and at what time scale that sensitivity changes. But we can see that throughout the year, air temperature has a positive impact on water temperature. And we can interpret the y-axis as the change in water temperature per change in air temperature. So for most of our long-term sites, that value is very high from late spring to early fall and around 0.3, which means that a 1 degree Celsius increase in air temperature leads to a 0.3 degrees Celsius increase in water temperature throughout this time. And based on this, we can conclude that the summer is highly vulnerable to warming. Moving on to the spatial data, we can look at the average max temperature of each reach, and we can see that some of them are highly warmed with about 20 degrees Celsius max temperature in one headwater, while another headwater had 12 degrees Celsius max water temperature. In addition to this variability, we noticed this big drop in water temperature, which is really interesting. And looking back on when we were going out there, there was a lot of fire smoke, and looking at some of the light data that we had, we can conclude that this is likely due to wildfire smoke causing a sudden synchronous decline in water temperature. And it'll be interesting to see what the creek fire impacts have on water temperature that's been recorded for the rest of the year when we look at that data. And in answering our spatial scales question, we used a multivariate autoregressive or MAR model to answer this. And we found that the reach scale best explain water temperature variation. And this means that managers should consider the 50 to 100 meter reach of a watershed as what might be vulnerable to warming or resilient to warming for modeling or for conservation efforts. In addition to this, we found that mean and minimum water temperature were improved with the inclusion of air temperature as a covariate to predict water temperature. So both of our first 2 sub-questions support the importance of including air temperature as a covariate for high-frequency water temperature data. Moving on to the third sub-question for the environmental drivers behind this vulnerability, we found that elevation was always important as a driver. As we increased in elevation, water temperature tended to decrease. And this is likely due to both reduced air temperature and increased amounts of snowpack, which will both be affected by climate change going forward, which is a concern. We also found that increases in conductivity led to increased water temperature. And this is likely due to shallow snowmelt that has a very low conductivity, resulting in some headwaters having lower water temperatures for mean and minimum than others, which is also a concern for climate change, given this is one of the main drivers. And lastly, we saw that discharge had a negative effect on water temperature, which makes sense given that reduced thermal buffering in small streams likely leads to a higher susceptibility to warming. But discharge is also likely to increase if we have reduced snowpack and reduced precipitation with climate change. So all of these are reasons for concern. And even though we understand the environmental drivers of water temperature, we need to understand whether this matters more so than what's happening upstream. And to answer that, I used a spatial stream network model, or SSN model. And we found that upstream temperature tends to matter much more in explaining variation in water temperature than what's happening at the local level. So we really need to consider managing for the entire watershed and not just at a local reach scale. And we can observe both the modeled results from the spatial stream network model and also the observed values. And we can see here they agree fairly well, with the observed values being the points with the white halo and the modeled values being shown in the actual watershed itself. And this just demonstrates that as we increase in elevation, there tends to be cooler max temperatures. And our smallest site, H1, a small headwater at low elevation, had peak max water temperatures compared to some of our other main stem sites that were larger. And even though we understand that the Sierra Nevada streams are likely to be vulnerable from answering these three sub-questions, we still need to understand whether it actually matters to the ecosystem. Will the taxa that are there be affected by warming? And to answer that, we can look at the current suitability of habitat now and whether that will change in the future. And here I am graphing the percentage of taxa that are vulnerable at each temperature based on their CD75 value, which is that temperature at which 75% of occurrences of an organism occur at a lower temperature. And if we look at the current distribution of habitat thermally, we can see that the taxa are well suited. The distribution of temperature habitat in Bull Creek based on our best model matches really well with the current thermal preferences for the organisms that live there based on what Dave Herbst has done in collecting samples. However, based on our analysis on our first sub-question of thermal sensitivity and finding that 0.3 value of a 1 degree Celsius increase in air temperature causing a 0.3 degrees Celsius increase in water temperature, and predicted increases in air temperature of 6 degrees Celsius in this region of the Sierra Nevada. In the future, we might see a large mismatch between the availability of habitat and the thermal requirements of organisms to survive. So many of the taxa, especially EPT taxa, mayflies, stoneflies, and trichoptera, might be removed from the system and not be able to survive going forward. So in conclusion, increased air temperature will increase water temperature during the summer, and there is reason to believe that streams will be vulnerable in the Sierra Nevada. The thermal vulnerability tends to vary at the reach scale, which means that we should consider 50 to 100 meter reaches as the area at which water temperature is likely to vary. And we found that elevation, discharge, groundwater, and snowmelt are all important environmental drivers of water temperature and sensitivity, which is concerning given that all of these are associated with climate change and likely to be affected by climate change going forward. And we also saw that upstream temperature mediates thermal vulnerability, which means that we should conserve the entire watershed and not just doing local restoration efforts to manage for water temperatures that are likely to increase in the future. And lastly, taxa are currently well adapted to the thermal distribution of habitat, but warming threatens many and is likely to change the ecosystem in the Sierra Nevada going forward. With that, I'd love to thank all the people who've helped me out with this project and the funding that I've gotten from a couple of different groups, and especially thankful to Cal-SFS and the Water Symposium for hosting me here. I'm happy to take any questions.
Awesome. Thank you, Kyle. It's super interesting work that you have going on. Peter, are there any questions for Kyle?
Yes, we have one question. The observation that thermal sensitivity is time varying was really interesting. Some months are more sensitive than others. How does that match with insect life histories?
Yeah, that's a great question. And a lot of insects are going to vary for when they're going to emerge or what resistance strategies they have if a stream does go dry or if it becomes not well suited for survival. So it'll depend a lot depending on the taxa. And if we looked at the EPT taxa being more vulnerable a couple of slides ago, we could see that some tasks are likely to be more affected than others by vulnerability. And there's especially high vulnerability during early spring for small streams. I think this was due to snowmelt causing a lot of suddenly warmer water traveling over the land, entering the stream and warming it suddenly. But I think that the really critical period will be during the summer in August and July, where a lot of taxa might reach their thermal maxima, or there's the highest chance of them experiencing max temperatures. So some organisms are already well adapted to emerge before that, so they're not going to be exposed to those temperatures, while others that are surviving in the water at that time are likely to be most vulnerable.
Great. Can you use SSN to predict refugia across the network, i.e. what habitats may not ever warm up?
Yeah, so I think for future predictions, there's a case of whether the entire watershed will warm at the same rate or not. And I would say that smaller streams are likely to be more effective than larger ones if they're most likely to go dry. And they also have the most change per reduction in discharge. But we can model changes or predictions for some of the parameters, like for water temperature, we could predict it throughout the watershed. So if we could predict for an organism, its habitat and its abundance throughout the watershed, which we have macroinvertebrate data to do going forward, we're going to try to predict which area is likely to have the lowest abundance of certain species and which ones are likely on the cusp of being vulnerable.
Great. And one more question. If you were developing a long-term monitoring plan for your study watershed to track the warming changes you mentioned, what would you most prioritize in designing this plan?
Yeah, so I think based on the spatial scale question that I had for which spatial scale we should monitor at, we found that it was the reach scale. It's a little redundant to have so many sensors within 50 to 100 meters. And it's better just to have maybe 1 or 2 sensors in that space to be able to deploy sensors at a larger time scale. And I think it'll be great to see water temperature going forward in Bull Creek, but also to compare it to some other headwaters nearby in the larger Deer Creek watershed near Shaver Lake and the Washone Reservoir. And that'll help us to understand differences between watersheds where some might have more groundwater influence or more snowmelt influence.
Great. Thank you. That's all the questions we have right now.
Yeah. Thanks.
All right. Thank you, Kyle. Excellent talk. All right. So moving on to our next speaker, Alyssa. Alyssa is going to be chatting with us about functional flows and how we can use those to establish flow criteria in California's South Fork Eel River watershed. So moving up to the northern part of the state. Alyssa, are you on with us? Okay.
I am. Could you advance to the next slide, please? Thank you. So yes, like Ali said, my name is Alyssa Obester, and I am an environmental scientist at the California Department of Fish and Wildlife within the In-Stream Flow program. And today I'm going to be talking about a project that I've spent a lot of time working on, where we are using functional flows to establish flow criteria in the South Fork Eel River watershed. Next slide. So a little bit of background on flow management to get us started. So in California, as in much of the West, managing flows is challenging, particularly given competing water uses. And traditional methods for determining species flow needs and balancing those needs with other water uses are typically time and resource intensive. And these methods don't always capture the variability in flows that's so important in California's river systems. So due to these challenges, there's this need for the rapid development of environmental flows that are consistent across the state. Next slide. So to address these challenges, the California Environmental Flows Framework was created by a diverse group of partners from state agencies, nonprofits, and academic institutions. And the framework provides guidance and tools for managers to develop flow recommendations at the statewide scale. This also helps managers improve the speed and consistency, as well as the standardization and technical rigor in establishing flow recommendations statewide. Next slide. And the California Environmental Flows Framework, or CEF, uses a functional flows approach for determining flow needs. And this means that it focuses on these components of a river's flow that support critical biological, chemical, and physical functions. And so in this hydrograph that we're looking at, these key aspects or functional flow components are indicated by the colored boxes. And so if we look from left to right, that orange box represents the fall pulse flow. And this is that first major storm event that follows the dry season. And key functions of this event include flushing nutrients downstream, supporting riparian vegetation, and providing cues for aquatic species. Next, in the dark blue rectangle are the peak magnitude flows. And these are those large-scale flow events in the winter that transport sediment, inundate floodplains, restructure the river channel, and maintain habitat diversity. Next are the wet season base flows, and these are defined by that prolonged period of elevated base flow during the winter, like their name suggests. And these flows support migrating and overwintering habitat for native species. Then in the green box are the spring recession flows, and these represent the transition between high and low flows. And these gradually receding flows redistribute sediment deposited by those higher flows earlier in the year, and they also provide important cues for aquatic and riparian species. And then lastly, in the yellow box are the dry season base flows, and this is generally the most sensitive period of the year for native species, during which both the quantity and quality of water limit habitat suitability. Next slide. And functional flow components are quantified or described by functional flow metrics. These are presented in the table on the right here. And these include the magnitude, timing, duration, and rate of change of each one of those flow components, or the boxes on the hydrograph. And so if we look back at the hydrograph, that blue line represents what we might think of as a natural flow regime in a snowmelt system. And the red dashed line represents a functional flow regime, where we see that the functional flow regime hits on those key points of variability throughout the year. And this is a key strength of the functional flows approach, because there's this explicit communication about the importance of variability within the year and across years. And like I mentioned previously, the functional flows approach is a key part of the California Environmental Flows Framework, and the framework and its tools and products are based on this approach. Next slide. So we at the California Department of Fish and Wildlife In-Stream Flow Program, we've been involved in the development of the framework. And a key product of this framework is a set of functional flowmetric predictions for every stream reach in California. And so we're using this product to develop flow criteria. And so for the rest of this talk, I'm going to be talking about how we're actually doing that in two different ways. Next slide. And a little bit of background before I dive into that, just on the watershed that I'm going to be talking about. So I'm going to be presenting on the South Fork Eel. And look, this is located on the north coast of the state. And it was identified as a priority stream by the California Water Action Plan, as it supports this really diverse array of salmonids, including Chinook and coho, as well as some other species of interest, including hardhead, lamprey, and several species of sculpin. There are no major dams on the South Fork Eel River, but there are numerous water diversions related to cannabis. And the in-stream flow program was tasked with identifying in-stream flow needs for this watershed. And so this is an example of a case where we have this large watershed, a lot of species, where we want in-stream flow information over quite a large geographic area. Next slide. And so to get at this information, we've developed what we call a watershed-wide criteria report, which, as the name suggests, it's a rapid approach for developing watershed-wide flow criteria. And these are developed using existing hydrologic and modeling tools like those provided by the California Environmental Flows Framework. And these can be combined with site-specific data when they are available. And so we're preparing a watershed criteria report for the South Fork Eel. and I'm going to dive into what's in that report in the next couple slides. Next slide. So the first step in these reports is to examine the reference hydrologic patterns in the watershed, which we refer to as base hydrology. And doing this helps us get at some context to work with when we're developing flow criteria. So our first analysis is what we call flow variation. And this is where we obtain gauge data for a reference gauge within the watershed. And we look at the variability of flows in the wettest, driest, and median year within the period of record. And we plot these data in a hydrograph like the one on the right here. And this helps us visualize both the inter and intra-annual variability in flows within the watershed. And then looking at the hydrograph, you'll notice that there's also that black line towards the bottom. And this is our second base hydrology analysis. And these show the median monthly natural flows. And these come from the Nature Conservancy's Natural Flows database. And these show the median monthly unimpaired flows within the watershed. And we also use these median natural flows as an input for some of our other analyses. Next slide. So after we gather that background base hydrology information, we then use a functional flows tool from the California Environmental Flows Framework to obtain the estimated functional flow metrics by water year type. So on the slide here, within the table, we're looking just at a subset of those functional flow components. So just for the fall and the wet season base flow. And these are, like I said, presented by water year type, as you can see in the 3 columns. And looking at an individual cell, the first number presented is the median value, or the value of that flow metric in about 50% of years. And then the number in parentheses next to it represents the value of that flow metric in 80% of years. And so if we just focus on one of these components, the wet season base flow, to better understand what these numbers actually mean, if we look at wet year, wet season base flow, you'll notice that in wet years, the base flow magnitude's about 1,000 CFS, but ranges between about 600 and 1,300 CFS in 80% of years. The wet season lasts about 135 days and typically starts around November 16th. And then we also, in our reports, display these metrics in the form of a hydrograph like the one on the right. And this hydrograph in particular represents the functional flow metrics in wet years. Next slide. And so functional flows are a centerpiece of our watershed criteria report, but we also present a couple additional analyses to provide some supplemental information on ecosystem and species-specific flow needs. So our first are the ecosystem-based flows, and these are these monthly flows needed to preserve a healthy stream ecosystem. They are calculated as a % of monthly and annual natural flows using Tessman's adaptation of the Tennant method. These are also used in the Water Board's cannabis policy. And these are presented on the right here on the hydrograph as a black line with those median monthly flows provided for some context. And then in addition to that, we also present salmonid habitat optimum flows. And these are the flows that maximize usable habitat area for salmonids within a given reach. And these are based on a synthesis of PHAB-SIM equations for the Western US. Next slide. So then we take the results of those, the functional flows and those additional analyses, and we begin the process of developing flow criteria using those functional flows as a starting point. And the functional flows help us answer the question of, what are the flows that are needed to preserve the ecological and physical processes both throughout and across years. And then we use those additional analyses that I was just talking about to understand any specific ecosystem or species-specific flow targets. So for example, we could use an ecosystem-based flow value for the month of January or February as a check and compare it to the wet season base flow value for a given water year type. Next slide. So we take those functional flow metrics and develop flow criteria for a flow regime for a particular location of interest. You'll notice that that final flow regime on the right incorporates all of those functional flow components. And this is for one location within the watershed, but you can imagine that with the tools and the method that we've laid out here, these criteria could be developed for any reach within the watershed. And in this example, you'll notice that all of these results came from either models or existing data sets, but you could imagine that these functional flows could be paired with site-specific data if they were available. Next slide. And so really briefly, this is what we did in Redwood Creek, which is a tributary to the South Fork Eel River. Our program performed an intensive field study in Redwood Creek. It was selected due to its high water demands and potential to provide habitat for a variety of salmonids. Flow criteria were developed using a combination of functional flows and field data, and these were developed for 10 reaches. Next slide. And so these flow criteria were developed through site-specific work that I just mentioned, and were compared with functional flows to ensure that each one of those 5 functional flow components were incorporated into the final flow criteria. So on this plot, those colored boxes represent the range of functional flows in 80% of years, and the black line represents the flow criteria that were developed via the site-specific methods. Next slide. And so each one of those 5 functional flow components were examined to assess how well they represented the field-based flow criteria that were developed. And so then we also incorporated the peaks and pulse flows and the recessions into the field-based criteria so that the final criteria were this hybrid of field-based criteria and functional flows for 3 water year types. Next slide. So to wrap up, the in-stream flow program has found functional flows to be a really helpful and flexible tool for developing in-stream flow criteria, both in the watershed criteria report and in the site-specific study in Redwood Creek. These flows clearly represent the interannual and seasonal variation in flows in a way that other methods don't necessarily do. We incorporate variability from the outset as part of our flow criteria. These can be rapidly developed using these functional flow tools. And as we showed here, they can easily be combined with some of the more traditional field methods to develop a more comprehensive set of criteria for a reach of interest. Next slide. So with that, thank you all for listening, and thank you especially to Cal-SFS for this fellowship opportunity and the chance to attend and participate in the annual SFS meeting. And I'm now happy to answer any questions that you might have.
Great, thanks, Alyssa. Peter, do we have any questions for Alyssa?
We do. Tying this great work of CEFF with Melissa's presentation, what other types of watershed or management applications do you foresee this type of analysis being useful for in natural and other systems?
That's a good question. So in this case in particular, because this was part of the water action plan, we're going to be providing these criteria to the board to consider when they're developing their flow objectives and recommendations. But these tools could also be used by those water managers working on the ground to establish flows or prioritize areas for flow restoration.
Okay, and I have another question. Can this be replicated on streams without gauges?
Yes, so those functional flow metric predictions are available for every stream reach in the state, regardless of whether they're gauged or not.
Oh, wow, great. That's all the questions we have right now. Thanks.
Thanks.
All right, thank you so much, Alyssa. Great talk. All right, so moving on to our next talk, we've got William Oda. Will be chatting with us about the Santa Ana River and opportunities from working in an extremely disturbed system. Turning it over to you, William.
Great. Thank you all so much for spending so long and sticking around for my talk and listening to me. So I'm going to be sharing a little bit of data and a little bit of narrative about the Santa Ana River and what I see as opportunities for freshwater ecology moving forward. And I have this quote that is from 2 of my favorite authors that I constantly am citing, Roy and Walsh: "The growth of new cities and urban renewal in aging cities provides unique opportunities to advance stream ecology." So what am I focused on in the field of freshwater urban ecology? The first are what challenges there are that exist. The first that I focus a lot on are the advanced spatial and temporal disturbance regimes that exist within urban areas. The second is novel species, specifically the introduction of either non-native or invasive species, depending on the impact they are having. And the third that I like to focus on is what effect is anthropogenic or human infrastructure having in these areas. And there's this great figure from McKinney in 2002 that looks at how species richness declines as we have increases in impervious surface area. So a lot of my work focuses on the species that are really into this area and will probably be classified as adapters or exploiters. When I'm looking at this and trying to address the challenges that I believe exist within urban ecosystems, I think about a few different mechanisms. The first is the selection and dispersal of primarily native and then novel species within urban habitats. The second are predator-prey or trophic interactions within these habitats and how they're being altered by an urban versus non-urban landscape. And then finally is life history alterations. And this can be both the most informative, but also the most challenging, at least for me to examine in my current study system, which we're getting to next. So I work in the Santa Ana River, and I think I have a bit of a inflammatory title when I say this is an extremely disturbed river, but I think it's also an accurate way to think about what is going on here. So the section of the Santa Ana that I work on stretches from San Bernardino to Riverside counties. It is bounded by two dams, Seven Oaks Dam on the north end and Prado Dam on the south end. There is a stretch of dry urban river below Seven Oaks Dam before the river is re-wetted by primarily treated wastewater from two facilities, and then supplemented by a variety of other urban wastewater facilities downstream, with a third being the primary source. So there's extremely limited dispersal into and out of this urban river habitat due to dams and also drying of the river. There is quite a lot of channelization and impervious surfaces that have been introduced for a variety of reasons. Wastewater provides a highly altered hydrologic regime from the traditional boom and bust flooding and drying that we see in this sort of very dynamic Southern California Mediterranean watershed. And then lastly, there is a variety of novel community members that have been introduced for recreational purposes or accidentally or as a form of biological pest control. I have a list of our extant and non-native community members that we can reference in the questions if you guys want to ask me about them. But what I focus on right now are a few different species of interest. The first is the Santa Ana sucker, which is a threatened species federally. The second is the arroyo chub, which is a California species of special concern. And the third is a really important predator of these two native species, the largemouth bass. So the rest of my slides are going to focus a lot on the interactions between these three species and how they contribute to the community as a whole. So questions and hypotheses, I kind of covered these when I talked about mechanisms and other things, but how is the Santa Ana River changing over time? And we would hypothesize that there's a decrease in community diversity over time due to these increased urban alterations, specifically wastewater introduction. And the second question is, how are changes in the community affecting trophic relationships? So that we predict that wastewater and the introduction of novel species are sort of reducing the number of interactions and simplifying the food web that exists within this urban river. So I'm going to go a little bit into communities over time. Secondly, I'm going to cover some trophic interactions. Third of all, I will go over diatoms in the Santa Ana sucker and some future work that I have planned. And then I will go back and cover SFS at the end, along with some other opportunities that I see from working in this system. So a lot of this work wouldn't have happened without great mentors, including my advisor, Kurt Anderson, and Larry Brown, who's pictured here, snorkeling for native fish in the Santa Ana River. And thanks to all their work and some of the monitoring of the Santa Ana that began in 2015 and is continuing to this day, to today, we can see that this river has decreased in diversity over time. So in 2015, after we found out the Santa Ana River was running dry during wastewater shutdowns, preservation projects for our native species of fish began, and we saw small increases in diversity that were non-significant. But then in 2018, we actually see a major decrease in diversity. So what could be causing this? And specifically, we see a decrease in the number of sites that contain native species. And when we look at this and we check out the largemouth bass population, we see that there was a major community shift in 2018 following groundwater wells going online. What this did was normalize flow, which Melissa talked about in the first talk of this session, and we saw a massive increase in the largemouth bass population. So what we thought was a conservation project that was going to preserve our native species that were getting trapped in wastewater shutdowns and river dry downs, instead may have been actually the cause of a massive increase in a large invasive predator in the Santa Ana River. And we saw just huge decreases, specifically in the arroyo chub population. So as we think about then how this new community will interact with one another, I decided to do a little bit of work on isotopes and trophic interactions in the Santa Ana. And I completed a small project that looked at trophic interactions across the two wastewater channels that re-wet the Santa Ana River. Key differences in this upper channel in orange, we see a collapsed food web where we primarily have macroinvertebrates and then largemouth bass and yellow bullhead catfish dominating the food web. And then in the lower channel, where we have a sort of expanded food web, we see some native species come in, and we see a much larger isotopic niche that largemouth bass, yellow bullhead, and mosquito fish are feeding in. What was most interesting was that Santa Ana sucker do not fit into our food web. They are at a higher trophic level when they're looking at isotopic nitrogen than their predator, the largemouth bass. And this is something that we struggle to reconcile. It goes against both sort of natural history and observations in the field. We've found largemouth bass that have recently fed on Santa Ana suckers, so we know that they are predating upon them. And what we're currently doing is exploring causes of this confusion. So it could be that there's a lifespan difference between collected Santa Ana sucker and the largemouth bass. So they are sequestering higher amounts of enriched nitrogen from the wastewater. The Santa Ana sucker's food supply could be more enriched from the wastewater than the largemouth basses, or we need to reassess which largemouth bass can actually predate upon Santa Ana sucker and do a deeper examination of life history. Lastly, some future work. Here is the confluence of the two wastewater channels that I mentioned. On the left is our lower channel, where we see heavy diatom and algal growth. And on the right, we see the upper channel mixing with it, where we see a more sandy, natural rocky substrate. And our preliminary results suggest that diatoms are not equally distributed within the Santa Ana River, and they are an important food source for Santa Ana sucker. And also that there is a preference by Santa Ana sucker for certain diatoms to feed upon. And this is work from a previous student that shows that the percentage of different diatoms in Santa Ana sucker feces differed from that collected from the river itself. So we want to assess how diatom communities differ across the Santa Ana River, and we're looking at 8 different river reaches. Determine if Santa Ana suckers have preferred food sources using preferential feeding trials and behavioral analysis. And then lastly, we want to examine, does the current distribution of Santa Ana sucker match their feeding preference? So are they altering which habitats they're residing in to maybe get to better food sources, or are they avoiding predation from this new novel predator, the largemouth bass? All of this really comes about because there's unique opportunities that come from working in a disturbed river. There's a variety of work, including native species surveys to sort of find and count our native fish. There are conservation plans and a variety of agencies who all have cooperated with me and really empowered me to do this work and make it possible. So without them, I would not be here. And then at SFS, I really enjoy just going to a variety of urban ecology talks. They brought me a lot of different perspectives. I attended the policy section meeting of SFS for the first time, where I learned a lot about how, as freshwater scientists, we can engage in policy. And then I also have some experience working with the National Science Policy Network and the UC Riverside Science to Policy chapter, if anyone has questions about that and how I connect my science to the policy world. I built new connections with both the Cal-SFS fellows and others. And lastly, in order to prepare for my new field work that's beginning actually tomorrow, which is very exciting, I attended the diatom identification workshop. So I really appreciate all the sort of lessons and opportunities that being a Cal-SFS fellow has provided for me. Thank you so much for listening, and I would very much like to thank and recognize the caretakers of the land and water and air that I work on in Riverside, the Cahuilla, Tongva, Luceno, and Serrano peoples. And before I let you guys all ask questions, I wanted, in case you hadn't seen it, share a link with all of you. This is going to a new proposed rule from the U.S. Fish and Wildlife Service that would open hunting and fishing rights within 90 national wildlife refuges, and comment closed July 6th. If you hadn't heard about it, I would encourage you to submit a comment so that they hear from all of you who I think are invested in water and natural resources in the U.S. So thank you, and I'm ready for questions now.
Awesome. Thank you so much, William. Excellent talk. I'm going to turn it over to Peter for questions.
Thank you, William. Are the data sets you are presenting on available and accessible as open data somewhere?
Yes. So the isotope data should be posted soon. We're still finishing up all the cleanup of that, but we should post that on USGS's, I believe it's Open Science or whatever USGS's website is, and that's where we get all our community and environmental data. So USGS has posted it. If you message me afterward, I'll put my email in the chat. I can share that direct link to it with you because it's saved under some weird file name that I have to copy and paste in from my notes every time, so the correct result pops up.
Great, thank you. That's all the questions we have right now. Oh, I'm sorry. What role do you think effluent should play in the future of the Santa Ana River?
Yeah, so I have a lot of thoughts about this, and I'll keep it condensed to the few pertinent ones. I think effluent is really the only thing that's keeping this urban river alive. Even if the dams are removed, I still don't know how much water would make it down to the ocean from just the natural headwaters. So without it, I don't think we would have our extant populations of Santa Ana sucker and arroyo chub in the Santa Ana. But I think the way we have studied and normalized flows actually is extremely detrimental to Mediterranean fish species, or just most of our freshwater species here in Southern California. I would love to see and encourage municipalities and other groups that have sort of regulatory authority over this to begin managing wastewater outflows the way that would match them with historical hydrologic regimes. And that could do a lot to sort of prevent both non-native species establishment and allow native species ecological history or evolutionary history to benefit them in chances to sort of reestablish themselves in a way that they're not threatened and endangered.
Great, thank you. That's all the questions we have right now.
All right, thanks again, William. Okay, so just real quickly before I turn it over to you, Angela, I just wanted to say that these talks have been awesome. I think they've really touched on, as freshwater science does, it touched on different cultural and social and ecological aspects and how things really are all connected. So thank you all for that. I also just wanted to mention, I think we have a slide later on this, but if you liked what you heard today, in October of every year, we do an event with Cal-SFS, a joint meeting, the California Aquatic Bioassessment Work Group meeting, where we have similar talks like this. So I won't spoil it. I think Angela's going to talk about it. And with that, Angela, I'll turn it back over to you.
Thanks, Allie. I'm trying to, it says I have control. Okay, there we go. Great, thank you. Okay, so yeah, thanks again so much for having us here and having this special session for Cal-SFS. We really appreciate it. And again, if anybody's interested in joining our chapter and joining SFS, here is the email that you can send a note to us. Even if you have questions about anything today from the presentation, we can make sure it gets to the right presenter as well. And then if you know, we do run off of our, we get some grants, but the chapter dues are what support our students, our early career scientists, and all the activities that we can do for our chapter. So if you're interested, you know, in supporting our chapter, we do accept donations, and we do have a Venmo, so it's really easy. And you could just look up Bendo. This is our treasurer at Cal-SFS-John-Olson. And again, follow us on Twitter at Cal-SFS Social. We have been tweeting throughout the presentation today. There we go. And so we do some upcoming events, as Ali alluded to. So in October, the 12th and the 13th, it's a Tuesday and Wednesday, we are having the California Bioassessment work group. And we are planning for it to be in person. Cross fingers. It'd be so exciting to see everybody face to face and interact and network. And this is also where we have our annual Cal-SFS meeting. And we're going to have a workshop on tribal ecological knowledge. We're developing that now. If there's anything you would like to see as a member, you know, for Cal-SFS, if there, we are, you know, putting on the workshops to help the membership. So there's something that, you know, as a member, you would like to know more about. We've had our visualization workshops before. We have early career panels. We've had other sort of data intensive workshops before. So it's really, this chapter is made for the members, to help the members as the future of freshwater scientists in California. And so look out for that save the date for the bioassessment work group. And I believe the abstracts call is in August. Ali, I think that's correct. Correct me if I'm wrong.
July 9th.
There we go. Okay.
Which we might push out. So yeah.
Yeah. And we usually do a poster presentation as well. So if you're interested in having some information shared there, or you have a student in your lab, or you know somebody that wanted to present, we also usually do a poster presentation as well at that event. And if you just want to learn more, we have a website through Society of Freshwater Science. You want to go to mySFS and then the California chapter. We also are developing a chapter website. Thanks so much to Christine and Ryan for putting that together. It's still in the development phase, but there are examples of previous posters and lightning talks, as well as previous meetings on that website right now. But we are going to be revamping it to make it more user-friendly and have more comprehensive content for the chapter. And again, if you're interested in joining Cal-SFS today, there is some specific things we like to develop, more focused meetings to make sure that we're serving those regional needs. We do focus on student and early career resources and opportunities. We provide lots of networking, professional growth opportunities. We have mentoring, information exchange with both the parent society, as well as other societies. Again, Society of Freshwater Science, we want to share information with other societies, agencies, organizations, and we really value the direct input from the membership on what local events we should do, where we should provide outreach, or should be involved with, as well as those outreach opportunities the chapter does. And then there's many more benefits. Again, this chapter is for the members. What we want to get out of it is what we put into it. And again, our email is at the bottom there. And then one more time, I just want to say what a great job to the fellows. You guys did a really good job today sharing your research. Thank you so much. All of you have a really, intense drive and desire to make science more accessible and more available. And I'm just so excited and proud of you guys today for your presentation. So good job. Thank you. And I hope everybody enjoys your break.
Okay. And Angela, jump in if you are there. Yes. So as Angela mentioned, we're still kind of grappling with if we're going to be in person or remote, or some hybrid approach. So that is potentially an option, and stay tuned. We're going to send an email out as the event gets closer with some of those details, but we're open to it. So short answer is yes-ish.
In the previous years, we had a lightning talk and poster too. So if you want to submit something that way, that can be available if you're not in person as well, if that was the question. Yeah.
All right. Thanks, everybody. And thanks again, Angela. Awesome work, fellows.